it down.
Okay.
Well, thanks everybody for joining. This is Fred Belli. I'm just going to give you a quick introduction here of how we're going to go process through this webinar. We're going to go through just a brief introduction of who we are, Driven 4, and then I'm going to pass it over to Bala, who will go through the why and what around the Smart Connected Lab, and then we're going to pass it over to Praveen, who's going to walk through the use cases and a demonstration, and then we'll open it up to questions. As Suk said, please provide any of your questions through chat, and we'll address those questions at the end of the session. So let me just do a quick introduction.
Okay, 1 second. Next.
There we go. Yeah. So myself, Valio, co-founder, managing partner, been working in industry for the 30 years, worked in the PLM side, both on the manufacturing as well as OEM. Right now, we've been in part of business for the last 4 years, and I'll pass it over to Bala.
Good morning, Bala Shetty here. As Fred mentioned, we've been in the industry for many years. I focus more on the manufacturing and the product development as well as PLM side of the industry capabilities. And within Driven 4, I take care of PLM as well as industrial IoT side of the business operations. Praveen?
Good morning, all. My name is Praveen Ike. I'm acting as a solution architect with Driven 4. I have experience in implementing PLM systems for medical devices, telecom, semiconductor, manufacturing, and aerospace defense organizations so far. Most of my experience is in PDC Windchill, but apart from that, I got exposure to Oracle Agile and Aras PLM as well. Thank you.
Well, thanks, Praveen. So let me just kick it off here just with a brief introduction of who we are. First off, thank you for joining us today. We're really excited about sharing what we believe is a great topic when you start thinking about how your company gets better at delivering innovative quality products to the market faster. I think connected labs and connected validation and verification through those connected labs is a great differentiator for you and your companies to think through as you go forward into your venture or product development. From our standpoint, we have come from 25 years plus, some of us a little more than the 25 years, but we come from your kind of background, your experience, right? We were in a lot of industries in the OEM sector, manufacturing sector. So we come from the same perspective as you guys and ladies feel as you attack these kind of problems and solution sets to them. The other thing that I really like to talk about is, when you think about our team, we've had our team together in multiple organizations. We've combined our team together, and we look at it from a perspective of, we believe we drive competitive advantage because we come with proven solution sets, solution frameworks that have worked in many industries, and we believe that is something that differentiates us as we go forward. The other piece as well is we always look at things from a holistic standpoint. We always want to make sure that you can drive the actual solution set from an expansion perspective. And then the last slide here that we just want to talk about, a lot of people talk about digital transformation, different focus, different context, depending on who you're talking to. From our perspective, the digital transformation is really centered around your product, the information around that product, how you drive that through innovation design into your operations, be it your connected operations here at your design centers for validation verification, but also in manufacturing, and then extended that out into your service arm and your connected products to your customers. So that's our intent when we look at a digital transformation. And with that, I'll pass it over to Bob.
Thank you, Fred. Again, I'm going to spend maybe a couple of minutes talking about the why and the what around smart connected labs. So from a traditional capabilities within an industry, what we see in the last 5 years, companies are trying to go from a PDM side of the foundational elements from PLM standpoint to do more and more requirements management and also doing systems engineering side of the capabilities, while doing the typical MCAD, ECAD, software data management, PLM. And we also see on the other side of the angle, the connected operations, smart connected products, how that is evolving the industrial pursuit of improvements or operational excellence. With that, we also see companies, connecting this data from end to end, all the way from consumer insights and those requirements, how that gets as an input to your overall innovation and technology and portfolio planning and the product road mapping, how that gets into the PLM side of the things to execute your new product introduction projects, and also how the overall collaboration and the closed loop solution is evolving within the solution framework, leveraging all of the latest technology evolutions, what we see in the industry, right? So with aspect to that, the smart connected labs is one of the areas, just like we covered in our previous webinar on transferring digital work instructions to your operations, factories, and remote operations. So, smart connected lab solution framework is also leveraging a similar frame set or framework of solution architecture. So what we see from our strategic business initiatives within product development companies, right? Pretty much every company, as we all know, while doing their typical yearly NPI, NPD, big projects, what are the other areas they're focusing to improve their day-to-day operations, right? What are the driving factors? So we see the focus on improving the product quality, and also how fast they can bring the product to the market, right? Time to market improvements, and also how they can enable certain capabilities within a company settings to improve the overall collaborations within product development teams, and also how they bring the data connected together to make those decisions from concept to production milestones. And also, we see engineering labs in most organizations having a traditional standalone solution framework and a traditional approach on how they receive test requests or work orders from different engineering teams, and also how they execute things and how they transfer that information back to engineering teams to make those product development decisions. So this solution framework will address all of those day-to-day activities managed within the lab operations, and also address some of the cost aspects and the productivity aspects of the workforce involved in those day-to-day activities. Some of the roadblocks we see or this solution is going to address is definitely how the processes are disconnected and the data is disconnected from the overall product development deliverable standpoint, and also bringing the information lifecycle together in a way that the test results are connected to the enterprise parts, to those requirements, and also the systems model if the companies are pursuing the systems engineering side of the things as a closed loop solution. And also, if the company is already launched the product in the market and they're looking at doing some fast track improvements within their subsystems or parts, the existing closed loop smart connected lab solution can fast track or can help fast track those activities tied to the validations with respect to those improvements. Moving to this solution, a little bit more details with respect to different capabilities, right? Praveen is going to walk us through some specific use cases and demo, but I'm going to talk more about the existing lab solution framework. There are a lot of hundreds of solutions out there. They all are monolithic, traditional, old technology solution framework set up to do the older way of managing the lab operations. None of them addresses the overall resource utilization or the capacity planning with respect to the lab resources, with respect to personnel or the equipments. So this solution pretty much brings all of the lab operations needs together. Uh, so we are talking here about leveraging PLM and some of the IoT technology. So PLM, as we all know, can bring all the test specification in a library, and those things can be connected to specific labs, specific lab assets, and also different compliance side of the connected information within the lab operations. So as engineers creates the work order for validation, this information can be looped in together in a way that it brings the information together for lab managers to assign and plan and schedule the activities within his labs. The solution also can bring the test results back into the PLM, right, to connect with the enterprise parts and subsystems, which has a lot more artifacts and information tied to them. So the decision makers within product development projects can quickly bring the information together to make those decisions. Resource utilization, the calendar entry for a lab or an equipment, having that visibility for all the engineering personnel is a big use case we see in the industry, where how the priorities changes when the company is doing multiple product development projects, and how the lab operations can be set up in a way that everyone can use the resources and equipments in an efficient manner. Um, then also we see industries leveraging some of the augmented reality capabilities for life cycle tests, for example, where engineers can walk into a lab and look at the live data in a way that it makes sense to them and also gives a different kind of experience to the people involved in the validation. Then the other C we see is, as I mentioned in my previous slide, the ability to bring all the data together, right? As the product is launched in the market, you get a lot of customer feedback and the field data, and you're also going to collect a lot of data in your end of line testing in the manufacturing assembly line. So ability to bring all this information together to drive continuous improvements and decisions around that product is a big advantage, and this solution supports that. And also we see some use cases where companies are managing the lab technician certifications and training records, or even the equipment calibration needs and notifications. All those framework is enabled within this solution framework. With this, I'll pass it over to Praveen to walk through a couple of use cases and a demo. Praveen?
Thank you, Bala. Can you please make me presenter?
Yeah.
Before you're getting into the demo, this is Pradeep here. I have a question, Bala. So this is collecting the end of the line testing or only the lab for the product development?
Yeah, today we are focusing more on the product development side of the things, Pradeep. PLM and leveraging ThingWorks side of the solution set, bringing the PLM side of the things more and more. But we have a customer who has enhanced this data connected to their manufacturing operations already to do some insights from it. It can be leveraged.
Okay, thanks.
Thanks.
Thank you for answering that, Bala. So I'm going to talk about the solution idea of connected lab, the implemented process, the high-level architecture, how it is implemented, and then a specific use case, and then a small demo around that use case. So the idea here is, or the solution idea is, the test lab will be connected. It will be online 24/7, and it will be connected to a cloud platform like PDC ThingWorks. The sensors, multiple sensors will be installed on each test equipment, and these sensors will sense the environmental data and push it back to cloud where PDC ThingWorks is installed. The collection of data will happen at the input and output parameters. Input parameters are captured because we want to capture the test environment, and output parameters so that an engineer can see the output or the judge the results. When we have such online and connected setup, there are some important benefits. So product improvement is the obvious benefit of such an environment, because you're going to improve your product testing visibility. When I say product testing visibility, what is going to happen is engineer will always have full log of test environment captured. which is not possible if the test results are captured manually. For example, if a test is being run for 20 minutes with automated data capturing with sensors, what we can do is we can capture input and output parameters each second of all 20 minutes. And we can store it in on the cloud in ThingWorks. So what engineer gets benefit of this is if engineer sees a spike in output in one of the parameters, he or she can go back to the log and go back to that one specific point in time and see what was the testing environment, what were the input parameters there, so that that spike can be justified. Snapshot of test environment at any point in time, just as I explained. Engineer can check the availability of testing environment and equipment at any given point in time, because this is going to be an umbrella solution which will cover connectivity from your engineering BOM design data until the test execution records. So all that connectivity will be present because this is going to be an umbrella solution. And because everything is at one place, tracking of test requests becomes easy. I'm sure today also test requests are present in the industry and they are being tracked, but the information is present in silos in multiple applications, and design engineer has to go through several systems just to track, just to see what is the status of the test request. Traceability between engineering BOM and test execution record, again, the same case. The information is there with the companies or the organizations today, but it is spread across multiple systems. With this solution, everything is under one roof, where engineer can see the design data, engineering BOM right there, and the historical test execution records connected to it right in the same system. Let's talk about the process. So very high level process is going to be like this. Engineer creates a request, adds test data. In most of the cases, it is going to be engineering BOM. Test instruction documents can be added. Now, engineering BOM and test instruction document mostly will be present in PLM system. In Windchill, let's say the engineering BOM is present in a product container and test instruction documents in a shared library container. So these documents and that engineering BOM can be added to test request by engineer directly. So I'll show you how that works in the architecture diagram later on. Then this request goes to lab manager. Lab manager's responsibility is to allocate the resources. So assigning the lab tester, test equipment will be done by lab manager, and he or she will schedule it for the testing. Then it goes to lab tester. Lab tester can execute the test, and the execution records will be automatically created on cloud in ThingWorks. So the lab tester has to connect those records back to the original test request. Now, once this test is complete, engineer can go back to the system and review the test execution record. Now, if you look at this flow is whatever is there currently in this in industry. So we are not altering the process a lot as such. What we're doing is we are just changing the medium completely. Instead of having it in multiple systems and with some manual steps, we are changing it to one system only and completely automated. Now, these are the three main environments in which this solution will be implemented. Windchill, which is going to be PLM system, where engineering BOM and test instruction documents will be present. ThingWorks, where all the data that is captured from sensors will be stored. Test requests will be created in ThingWorks. And of course, the test lab, because we are going to install sensors there. So test lab is important environment that we're going to touch in the solution. So these are the main business objects. In Windchill, engineering BOM will be present in product container. Test specification, test method, and these documents will be present in library container. In ThingWorks, the main important object is test request. Test request will be created and stored in ThingWorks. Test equipment is another object that will be created in ThingWorks. Test equipment is actually digital twin of the physical test equipment in test lab. Now, the logical entity test equipment will always be connected to physical equipment in test lab by means of sensors and network. Test execution records will be created in ThingWorks. All the data that is captured by the sensors will be available on these test execution records. This is how the linking between these business objects. Test request will be connected to engineering BOM and test specification documents, because engineer has added these objects when a test request is created. Test request will be linked with test equipment, because either engineer or lab manager is going to add test equipment to the request. Test execution records will be automatically created and automatically linked with the test equipment. Test execution records will also be linked with test request, because each record is meant for what's done or what's created because of a specific test request. So when tester tests in the lab with the physical data and devices, execution record is created and he or she will link it back to test request. So here is the high-level architecture of this system. We are going to talk about two main components: test equipment and cloud, and how these two components connect or be in touch with each other for transferring the data. Now, in test equipment, sensors will be installed. Sensors will be installed to capture input parameters and output parameters. The reason why we want to capture the input parameters, because as I mentioned earlier, if the engineer sees a spike or anomaly in the output parameters at some point in time during the test, he or she wants to capture or see what was the input parameters at that point in time. So the sensors will be installed at both places. Test equipment will also have an IoT device, which will have input-output connectors, firmware, microcontroller, and Wi-Fi connectivity as the functionality. So input-output connectors will be used to connect the sensors to the IoT device. Firmware is the actual software running on the IoT device for edge computing. Microcontroller is the hardware chip which supports with the software, and Wi-Fi connectivity so that the device can be online 24/7 and connect with the cloud. So in this case, the sensors will collect the data, send it to IoT device. IoT device can collect those data points using IO connectors and send it to cloud. Firewall will be present on cloud, and ThingWorks will be present on cloud. On ThingWorks, we will open few REST APIs. These will be integration touch points so that external IoT devices can be connected to ThingWorks. So when I say external, it really doesn't have to be online as in internet. It can be in your local LAN or VPN as well, depending on the organization's setup. So all the business logic will be present in ThingWorks. Now in this picture, again, I mean,
Did we lose him?
sorry, can you hear me now?
Yes.
Sorry, yeah, okay. Okay, so this is the high-level architecture of this system. So with that, we covered the idea, the solution idea, then we saw the process of how this test request can be registered and how the closed loop happens. We saw different environments that we're going to touch upon, and business objects that is going to be created and linking between them. Now let's look at a simple scenario, a specific scenario, and then we'll go through a very quick demo. So the scenario is like this. The manufacturer of industrial spray painting robotic arms uh, wants to test new spray pumps. Engineer wants to test the pumps. The product is industrial spray painting robotic arm. That arm is present, it is well tested, and engineer has designed two new pumps. We'll just assume that these two new pumps are variants of each other with a slight changes. The test that engineer wants to perform is like this. Engineer wants to test the pressure level applied by the pumps, and he or she wants to check what is the RPM speed of the spray arm. He or she has specified that the paint quantity that should be used in this test should be 4 liters, and voltage applied should be 230 volts. Voltage is important component because the pressure exerted by the pump depends on the voltage. So we'll just quickly go through a demo. So in this case, what we're going to assume is engineer has created a test request and it has gone through all the process. Tester has tested it, and ThingWorx has captured the data. So we'll just assume that entire thing has happened, and now engineer is going to review the results of the test in ThingWorx. So this is how the connected, result comparison looks like in connected lab solution. So here it is data captured by pump 1, and here is data captured by pump 2. In this case, because it is a comparison test, okay, engineer can do individual component comparison, because each arm has each pump has got two arms, arm 1 and arm 2. So engineer can actually test it or compare it with individual component. For example, engineer can test it with arm 1 of pump 1 and arm 1 of pump 2. Now, because as we have seen, he or she had specified that voltage applied should be 230 volts for both the pumps, we expect that the pressure received at both the arms of both the pumps should be exactly the same. But as in the result, we are seeing that, okay, these are not the same. So engineer can go back and try to figure out why there's a difference, whether it is because of the difference they have made in the variant design. Similarly, we can compare what was the pressure applied by the two pumps. Now, this is the pressure generated by the pump. Now, again, because it was 230 volt, ideally it should be the same, but we see there's a little bit of lag in one of the pump compared to the other one. Similarly, we can see on pump 1 how the pressure exerted by the pump and what is the pressure received at the arm. Again, ideally it should be the same, because that is the purpose of pump. Pump should create some pressure using that liquid paint, and arm should receive exactly the same amount of pressure, but that is not the case here. So engineer can analyze that. This was one parameter that engineer wanted to test, pressure at the arms and pressure at the pump. The other parameter was the rotation, RPM rotation speed. So here again, we can compare the rotation speed of pump 1 and pump 2 for arm 1 or for arm 2. So because this data is collected automatically, there's a stream of data available and stored in an enterprise system and with the graphical representation. It opens up a lot of ways for engineer to analyze the data. And with the full log, the possibilities of seeing the real test or visibility into the real test for an engineer opens up a lot. So this was all I had to cover. So we have seen the solution, the process, high-level architecture, a use case, and demo. So if you have any questions, please drop it in the chat box. I'll happy to answer those at the end of the session. I'll pass it on to Sukh now. Thank you.
Thank you, Praveen. That was a good overview of the application. I'm sure we have built up some curiosity in the audience, and we will go through the questions and answers soon if they want to learn more about or have any questions. I have few of the questions I'll go through. Let me see. I have a couple of questions here. So one of the question is, can you expand on managing the lab resources within your solution? Bala, probably you can take that.
Can you hear me?
Yes.
Okay. So you can also bring up the slide while we are talking about our contact information. So the question for everyone is about more elaboration on the resource side of the management within the solution framework. As we discussed, the typical day-to-day operations for a lab manager, right? Knowing what tests are tied to what lab assets and which of his team member is most suited for executing that test request. And also providing the visibility to his engineering colleagues within product development on what equipments or resources are available and what prioritized tests are scheduled to run in his lab on a daily, weekly basis, right? So this solution can bring up all that information together to drive the closed loop collaboration and also the data what we talked about. Now we see certain companies where they have multiple labs doing similar tests in multiple locations. They can enable this solution to really see the overall usage of their lab assets as well as resources, where we saw one initiative with one of our customers where this provided a lot of data for their consolidation roadmap for their overall validation and verification aspects, right? And we see some industries where this validation is looked as a testing as a service, right? They have external contract houses doing nothing but testing, where this solution can really bring up the closed loop collaboration with the product development teams and the lab operation teams. So with that, yes, definitely to answer questions, so this solution can do a lot more with respect to the overall management of the resources for both equipments as well as the personnel.
All right, that was a good explanation, Bala. Thank you. I have one more question. How this solution can help companies doing more and more system engineering within this product development?
Okay, so when we look at the typical product development, we all know the products are becoming more and more complex, right? With more and more electronics, hardware side of and the software side of the content coming together from the system side of the validations requirements. So if the companies are doing more and more systems engineering, system modeling, also managing the requirements as well as connected test specifications, this solution can bring and connect all that information together. We are also working with another company who is doing this technology for validation verifications for 30 plus years to really see if this solution can be connected with the simulation data to drive some of the virtual side of the understanding of product development to make some fast track decisions. We are testing that solution as well. Now, if you look at cooling as a system or exhaust as a system, like I said, there are definitely the critical parameters within engineering or what is typically captured as a DFEMA, right? Design failure mode and verifications. Those parameters can be captured in PLM as the deliverable attributes, right? The target attributes, and this test solution can capture that test value, feed it back to that attribute what is captured in PLM, and provide the automated results or the review notification to the engineers who are responsible for those deliverables, right? This is the power of this solution beyond the traditional way of reviewing what the engineer receives from the testing lab team members to go through the data to really validate the overall output. So this solution can be enhanced to support those kind of setup to automate things in areas where it makes sense to provide that fast track closed loop visibility. Hope that answers your question, sir.
Yeah, thanks, Bala. Thank you very much. I have another question, couple of questions come in just now. Just one is, the one is the lab request and the schedules managed in PLM or ALM?
Yes, the solution is primarily managed within PLM, right? For those customers who are utilizing PTC, Windchill, and then ThingWorks framework, this utilizes a solution framework, encompasses the navigate side of the features, but this can be made to work with any PLM, but it's primarily targeted to expand the PLM side of the utilization than ALM. And if the customer has ALM to PLM connectors using the OSLC adapters, we can connect those data as well, based on the requirements, preferably through the PLM as expected. But yes, it's primarily set up to run on top of the PLM solution framework. Last question.
Okay, one more question here. Have you deployed this solution? And I think I have one more coming up right now.
Okay, so yes, we have deployed this solution in Novi, Detroit, for a customer who is big into the development and manufacturing of pneumatic valves for medical devices. They also expanded the solution to their labs in Germany, Philippines, and India recently as the phase 2. And we're also working with 2 other companies in North America on the same solution framework.
Awesome, Bala. One quick question, probably the last one, I believe. Is this offered as a full test management product, and how easy it is to configure industry-specific lab management use cases?
Yes, so this solution framework is offered as a product in itself, because the amount of effort we have put into this solution, it's from last 3 years with respect to looking at the various aspects of lab operations, right? The managing the resources, their certification, equipment usage, and those calibrations, and also the day-to-day feedback loops and collaboration aspects between lab members as well as engineering teams, internal and external, right? So this is a product. Now this would be an easy enhancement for the customers who are on the PTC landscape for Windchill and ThingWorks. For other customers, it's an add-on module to enable things within their existing PLM and any other industrial IoT or IoT technology they have currently. If not, we can bring in the PTC solution framework to quickly enable the solution end to end.
All right. Thank you very much, Bala, for the very good explanation on those questions. I don't see any further questions at my side. With that, I think I would like to conclude this meeting with what's coming next. I hope you guys have enjoyed this session. The next session is the connected product development, role of PLM and IoT connected product development. role of PLM and IoT in product development, connected product development, I would say. So it's on October 7th, same time, 11 a.m. Eastern Standard Time. I hope you guys have enjoyed this and coming session interesting. If any other questions, feel free to open up your mute and ask. Otherwise, we'll conclude this session for today. Thank you all for joining.
Thank you all. We are all going to receive the deck and the recording of this session. And we have the contact information of Driven 4 within the slide deck as well. Thank you very much for investing your time and looking forward to hear from you guys. Thank you.
Thank you.